Have you ever just looked at a map and wondered how our planet can be such a place of extremes? You know, you've got these lush, green rainforests absolutely overflowing with life on one side of a continent, and then bam, vast parched deserts on the other. It's a huge global puzzle, and the secret, well, it lies in the story of our rivers.
So it really makes you wonder, right? How can one river system, like the mighty Amazon, carry about a fifth of all the world's river water, while other places nearby are just bone dry? Rivers that barely exist, appearing and then disappearing in a flash. The answer isn't just, oh, it rains more there. No, it's way more complex and honestly way more fascinating than that.
The best way to wrap your head around this is to think of every single river system as having its own unique recipe. A very specific mix of ingredients, all combined in a particular way, that decides whether a river is going to run wild and full or just struggle to flow at all. And today, we are going to break down that recipe ingredient by ingredient.
Okay, first things first, we need to understand the cooking pot itself, what we call the drainage basin. Basically, any drop of rain or snow that falls inside the boundaries of this area is headed for the same river. This is the blueprint, the stage where all our ingredients are going to mix and interact.
So what's the number one most important ingredient in our recipe? Well, that has got to be the climate. Think of it as the master control, the head chef that decides just how much water the basin gets to play with in the first place. Climate is the boss, period. It dictates two absolutely crucial things: the inputs, so how much rain you get and what kind of rain it is, and the outputs, how much of that water goes right back up into the atmosphere through evaporation. It sets the entire water budget for the basin. And you've got to remember, not all rain is created equal. You have those intense, short tropical downpours from the sun just baking the ground. You've got rain that's basically forced into existence when air has to climb over a mountain. And of course, that steady, gray drizzle many of us know and love, when warm and cold air masses have a little meeting. Each type totally changes how it hits the land below. And you can really see the results here. A tropical rainforest gets absolutely hammered by those intense, short downpours, which means a ton of water hits the ground all at once. Meanwhile, in a semi-arid landscape, rain isn't just rare, it's completely unpredictable. It creates a whole different world of challenges. So, here's what it all boils down to. It is a constant tug-of-war. How much water is coming in, as rain, versus how much is leaving through evaporation and being used by plants. This simple balance is what decides everything. It's what makes the difference between a water surplus that creates massive rivers and a water deficit that creates a desert.
Okay, let's move on to our next set of ingredients, the physical stage. This is the land itself. We're talking soils, the rocks underneath, and the very shape of the ground. All of this stuff plays a huge role in what happens to the water after it lands.
It helps to think of it like this. Sandy soil is kind of like a sponge. It's got big gaps and it soaks up water really fast, letting it seep right into the ground. Clay soil, though, that's more like a ceramic tile. The pores are tiny, so water can't get in easily and just runs right off the surface instead.
And then deep below the soil, you have the geology. A permeable rock, like sandstone, acts like a massive underground reservoir. It lets water trickle down and stores it for later. That stored groundwater is what feeds rivers and keeps them flowing all year. But impermeable rock, like granite, it's a barrier. It forces all that water to stay on the surface, which leads to rivers that are much more flashy and unpredictable.
And finally, there's the shape of the land itself, the relief. On gentle slopes, water has time to just kind of hang around and soak into the ground. But on steep slopes, gravity just takes over. Water has zero time to linger, it rockets downhill, creating super fast runoff and, as you can imagine, a much higher risk of flooding.
All right, let's talk about our next key ingredient. This is one that people often overlook, but it is incredibly powerful. We're talking about life itself, the vegetation. From a single blade of grass to a massive rainforest canopy, plants fundamentally change the water game.
Seriously, plants are absolute game changers. Their leaves catch the rain, softening the impacts so it doesn't just pound the soil. Their roots create these amazing little channels, opening up the ground and helping water soak in. They even breathe water back into the atmosphere. You put all that together, and a forest acts like a giant brake on the whole system, slowing everything down and preventing wild swings in the river's flow. And you can see the difference this makes right here. The dense rainforest canopy catches and recycles enormous amounts of water, which leads to stable, predictable rivers. But in a semi-arid place with just a few scattered bushes, there's nothing to stop the rain. It just hammers down on that hard, compacted soil and rushes away, causing those dangerous sudden flash floods.
Now, to give you an idea of the sheer scale we're talking about, in a typical tropical rainforest basin, you are looking at over 2,000 millimeters of rain every single year. That's a staggering amount of water.
And then you have this. A semi-arid basin gets less than 500 millimeters. That is a four-fold difference, at a bare minimum. It just goes to show you how incredibly different the starting points are for these two systems. So, we've looked at all the individual ingredients. Now it's time for the fun part. Let's put it all together and see the final recipes. See how all these factors combine to create two completely different worlds from the same basic blueprint.
See, it's never just one thing. It's the unique combination of all of them. The climate, the soil, the rock, the slopes, and the plants all interacting with each other that creates the final character of a place and the river that flows through it.
And this table just lays it all out, side by side. Look at the contrast. On the left, you've got the rainforest recipe. Massive rainfall, deep soils that soak it up, and a dense forest creating these stable, steady rivers. And on the right, the semi-arid basin. Low, unpredictable rain, hard-packed soil, and hardly any plants. It's the perfect recipe for flash floods and rivers that are here one minute and gone the next. And that brings us right back to where we started. This is it. This is the answer. The reason some rivers are steady and others are wild is the recipe. One is a recipe for abundance and stability. The other is a recipe for scarcity and volatility. It's how all these physical factors work together that gives us the incredible, dramatic differences we see all across our planet. But here's the final, crucial thought to leave you with. These recipes aren't set in stone. As our global climate continues to change, rainfall patterns are shifting, temperatures are rising, and that's going to alter the vegetation. So the big question we're left with is, as all this happens, how will these incredibly intricate and delicate recipes be rewritten in the years to come?